Now we continue with miscellaneous exercise. This is question number 4. Question number 4 is, if A and B are symmetric matrices, prove that AB minus BA is a skew symmetric matrix. So it's given to us that A, B are symmetric matrix. So A transpose will be equal to A and B transpose will be equal to B. Now we have to show that AB minus BA is a skew symmetric matrix. So let AB minus BA transpose we take, then you know the identity that A plus B transpose is equal to A transpose plus B transpose. So apply this here, AB transpose minus BA transpose. Now we also know this, that AB whole transpose equal to B transpose A transpose. So it can be written as B transpose A transpose minus this is A transpose B transpose. So B transpose is B because it's given, and A transpose is A is also given. A transpose A, this is B. But this inside this bracket AB minus BA, and this is BA minus BA. So what we can do, we can take minus common, so it becomes AB minus BA. So now you can see this is, we are getting the matrix transpose as minus of this matrix. It means this implies that AB minus BA is a skew symmetric matrix. Now come to question number 5. Show that the matrix B transpose AB is a symmetric or skew symmetric as A is symmetric, skew or skew symmetric. They want to say that B dash AB will be symmetric if A is symmetric, and B dash AB will be skew symmetric if B is symmetric. Let's start with this. So we write the solution. So take B dash AB transpose. So you can see this you take as one, this you take as another group. So it can be written as AB transpose, and this is B dash transpose. You can write transpose. You know that AB whole transpose equal to B transpose A transpose. So we are applying this. Now you see this AB, again we apply this. This can be written B transpose A transpose, and B transpose and whole transpose again, then it becomes the original matrix, so it becomes your B. Now this B transpose A transpose, this will be B A B transpose, and this is B. I'm taking A transpose as equals to A, means this implies that this is a symmetric matrix, because B dash AB we are getting BAB. So this is a symmetric matrix, and we have taken A as symmetric matrix. Now in case 2 will be, take A transpose equal to minus A, then it will be B dash minus A B. So it can be written as minus B dash A B. So you can see now this has come, this shows us that this matrix B dash A B is a skew symmetric matrix. So the result I think is very much clear to all, that in first case we have just taken transpose of the given matrix and open using the properties of transpose, and we have reached up to this condition that B dash AB. So now this answer will be there because A transpose we have assumed this as A. It means we have assumed A as symmetric matrix, so the answer is a symmetric matrix. Or now in case this, when we are assuming that A is a skew symmetric matrix, then this answer is coming minus B dash, which is B dash AB. So you see B dash AB, so minus is coming, so it means this is a skew symmetric matrix because A is a skew symmetric matrix we have assumed. Now come to question number 9. 9 is, find X if this x minus 5 minus 1 is this into this into this is equal to this is equal to 0 matrix. This 0 means not 0 as a scalar, this is a 0 matrix. So you always have to take care one thing, that the multiplication go from right to left. You cannot multiply these last two matrices directly. You multiply this matrix with this first, and whatever the answer comes you will multiply with this. And now you see this first matrix is order 3 cross 1, and this is 3 cross 3, and this is 3 cross 1. So first these two are possible because column number of column is, this is 1 cross 3, this is 1 cross 3, and this is 3 cross 3. So number of columns are 3, and here number of rows are number of columns are 3 and number of rows are 3. So it means we can multiply. So multiply this and we'll then multiply the resultant matrix with this. So x into 1 is x, minus 5 into 0 is 0, and minus 1 into this minus 2. Then you multiply, and second column you check 0 minus 10, and this will be then 0, so let it be, then it will be 2x minus 5 and minus this minus 3, and this matrix will remain as it is. Now multiply this with, now this is done. So your answer, you know that answer will be of 1 cross 3. So your, this is your 1 cross 3, and this is your 3 cross 1. So now you can multiply this further. X minus 2 into this, so x minus 2 minus 10 into 4 minus 40, and this is 2x, this is minus 8. So it will, after multiplying this, we will get the same result. So this will be plus 2x minus 5 minus 3, you can say right 8, and this is your 0 matrix, means 0. So this is now 1 cross 1 because 1 into 1, and this is also 1 cross 1. So equate them. This becomes x square minus 2x minus 40 plus 2x minus 8, and this is equal to 0. So this will be 2x cancel, this is x square minus this, and this will be minus 48 equals to 0. So x will be under root plus minus 48, and now 16 into 3 you can write this. So ultimately you can write plus minus 4 root 3. So this is your answer. So but this question why I have taken, this is very important to understand one important result. If there are 3 matrices in continuation, then you have to go from right to left. You cannot go from left to right, or you cannot multiply any 2 matrices in any of the order. So multiply in the order right to left. Come to question number 11. Again, this question number 11 is important because you have to apply some important results that you've already learnt in multiplication of 2 matrices. X is a matrix, this is a matrix, this is a matrix. So you know that when you multiply 2 matrix, and the resultant matrix is also, you know, have some particular order, cannot be of any order. So according to this order property, we can see that this matrix is of 2 cross 3, and you know that number of rows of this and number of column of this should be equal. So it means that 2 number of column of x will be 2, and we also know the resultant matrix will take 2 rows of equal to the rows of the resultant matrix. So it means if its row is 2, then this will also be 2. So this, using this property, now we got to know that x will be of order 2 cross 2. So let x be a, b, c, d, we have assumed. Now take these values a, b, c, d and multiply this and equate, and we'll get the values of a, b, c, d accordingly. So a into 1 is a, and this is plus 4b, and this will be then 2a plus 5b, this will be 3a plus 6b, this will be c plus 4d, this will be 2c plus 5d, this will be 3c plus 6d, and this is equal to minus 7 2 minus 8 4 minus 9 6. So now take any two, like a plus 4b equal to minus 7, and take 2a, or you can take 2a plus 5b equal to minus 8. So solve these two equations for a and b, and take this one, c plus 4d equal to 2, and 2c plus 5d is equal to 4. Now you know how to solve linear equation in two variables. So multiply these equation by 2, this is by 1, so it becomes 2a plus 8b equal to minus 14. This becomes 2a plus 5b equal to minus 8. Now you subtract, so this 2, this cancel, then this is 3b, and this is minus 6, so b will be minus 2. Now you put any in any of the equation, a will be minus 7 minus 4b from 1. Take this as equation number 1, this as equation number 2. Take this first one as equation number 1, this as equation number 2. So now it will be minus 7 minus 4 into minus 2, so this becomes plus 8, so this is 1. Therefore a equals to 1, b equals to minus 2. Come to this second set of equations. So again you multiply by this 2 1, so it becomes 2c plus 8d equals to 4, 2c plus 5d equals to 4. Subtract, this is 0, 5d, and this is 3d, this is equals to 0, so d is equal to 0. Now let's see this equation number 3, and this is equation number 4. So from 3 you can get c equal to 2 minus 4d, so answer will be 2. Therefore c equal to 2, d equal to 0. So we have got the values, but ultimately we have to write the matrix. So matrix will be a 1, b is minus 2, c is 2, and d is 0. So ultimately this is your final answer. Do not leave the answer in terms of ABC only. You have to write in terms of complete X matrix. Now question number 15, though this is a MCQ question, but it is important and we should discuss this in detail. If a square equal to a, then I plus a whole cube minus 7a, you have to find the value which is what value this term will have. So I have used this formula, a plus b whole cube. A plus b whole cube is a cube plus b cube plus 3a square b plus 3ab square, 3a square b plus 3ab square, so and last b cube. So I have applied this a cube plus b cube, 3a square b plus 3a square, 3a, 3 this a square a, and this 3a b. So whether you write I or not, it doesn't matter, this is fine. So now I cube will be I, a square, a cube can be written as a square into a, and 3i square into a will be 3a, because I square is ultimately I, and I into a is a, and 3ia square is again 3a. This is minus 7a from this equation, from this term. So I cube is I, this a square into a square, you know that a square is given us to a, so we'll use this. A square is a, this is 3a, this is 3a. Now a square we applied as a minus 7a, so this is I, a into a square, this is 3a, 6a minus 7a, and then I, this a square is a, 6a minus 7a, so a plus 6a, this is 7a minus 7a, 7a got cancelled, so this is I. So option number C is the answer, though it can be asked for even 2 marks also. So because of that reason I have solved it completely. So this we have completed our miscellaneous. Rest of the questions are of similar type, which you can try yourself.